Hello. So this is the continuation of group is that one the static group comparison. So as mentioned, we have to check if we satisfy the condition. So in the previous video, we already identified that t-test for independent sample can be used. However, one particular assumption that we again need to consider or to check is if we have equal variances or if there is no equal variances in our data set. So with this result, using the online calculator, particularly the Levin's test, as mentioned here, the requirement of homogeneity is not met. So we're going to use t-test for unequal variances. So we will go back to our dummy data and performed the t-test for independent samples. So to do that, so we have to click data, data analysis, and we can find here the t-test to sample assuming unequal variances because we did not meet the condition. So let's go back to the result again. So this is the result. It is significant, which means that we did not meet the condition. So anyway, you are guided with the conclusion here. So going back to the data, so t-test to sample assuming unequal variances. So click that. So for variable 1, so you have to select the data from 1 to 30 because this is the group 1. And then for our group 2, it is 31 to the last one is 60. So we did not place labels, but we are sure that the variable 1 is the group 1 and the variable 2 is the data for group 2. And then click OK. So this is now the result. So let's make this visible. Okay. So this is the result of two sample assuming equal variances. So you are provided, so you can already change the label here. So this is the treatment, or rather, as mentioned, it's the treatment group. Group 1 is the treatment and group 2 is the traditional or the existing or the control. So as you can see here, we actually even have higher percent score in the control group than in the treatment group. So for the variance, so as mentioned, you have to compute for the standard deviation instead of the variance. So that is equal SQRT, open parenthesis, select the data variance or the cell for the variance, and then just drag it. So this is now the mean, variance, and standard deviation. And also for the observations, we have 30-30. Degree of freedom is the, oops. So we have to check if we entered the correct data because we actually have 60 number of samples. So let us double check. Or rather, let's repeat doing the procedure. So let's click data analysis, equal variances, and make sure that we selected 2 to 31 and 32 to cell 32 to 61. Okay. So there is, of course, a different value for our So where is that result now? Here. So there is a different value for our degree of freedom simply because we used unequal variances. But assuming that we satisfy the Levin's test or homogeneity test, then the degree of freedom here is actually 58, wherein the formula is n minus 1 plus n minus 1, or that is 20, that is uh, 28 plus, sorry, 29 plus 29. Okay, you are also provided with the statistics here. So it's a negative 9.41. So as mentioned in the previous, it is simply because of the entry. So how we entered our data. So we have higher control group. That's why higher value in group 2. That's why it's a negative, because the entry is group 1 and group 2. And then let's go down. So assuming that we stated that we're going to use one-tailed, because what we are trying to say here or to conclude is the intervention, using the intervention is better than the control group. However, it seems that that is not the case in the given data. So you can use this value of a t-test and compare it with the table, or actually it's still already provided here, but if you do not have Microsoft Excel and computed this using manual computation, then it means that you can look at the value of the table, tabular value, and compare it, so you can find this value. But here, what we're going to do is just to consider the p-value. So it is 5.856. So as mentioned before, this is actually 5.86 times 10 raised to a negative 13. So it is almost zero, which means that the p is less than 0.01, which also means that it is significant at 0.01 level of significance. Therefore, there is a significant difference. The answer to the question is that there is a significant difference, but you have to justify, you have really have to make a good interpretation what happened and why do the students obtain a very high percent score in the control group and not in the treatment group. So not all the times that if you have obtain a result of there is a significant difference, then it means that it's already favorable on your side. Just like this, the result is that there is a significant difference. However, it turned out that the control group has higher percent score than the treatment group. So it seems that it is not effective at all, and it even and compared to the traditional, it seems that the traditional is even a better method than the blended learning. So but again, we have to consider that the experimental design use is the static, so it might be that it has something to do also with the choice of the group for the group 1 and the group 2. Okay, so this is all for this video. For some concerns, you can message me directly, or for some comments about the videos, clarifications, you can directly message me using the messenger. Thank you for watching.